Hi, my name is Michael Aline, and this is my EECS1011 main project. By looking at the simple flowchart here, we can discuss the first learning outcome. The algorithm that runs this program is dependent on the state of the button. So when we run the program, it'll enter into an initial while loop that says that while the button is equal to 0, it'll loop. And if we want to break out of that while loop to start the program, we press the button, equating it to 1. This will then enter into a second while loop that states that while the button is equal to 0, the if statement will run that tests the moisture readings to see if they are greater than the threshold value. If they're not, that means that the soil is saturated and the pump remains off. If they are, that means that the soil needs water and the pump will go on. This will continue to detect the readings to see if they are greater than the threshold value. If it detects one that is less or equal to the threshold value, this will equate to no, or the else part of the if statement, which will state that the soil is saturated and then the pump needs to go off. This will continue to loop until the button is pressed or equal to 1, ending the program. For the second learning outcome, using a combination of loops and conditional statements like while loops and if else statements, the algorithm's output will change based on the state of the button and the moisture readings. In order to turn all my voltage values into units of moisture for the third learning outcome, I used a function that computed a linear normalization function of the original voltage readings. It will simply transform the raw voltage values into values between 0 and 1, with 0 being the pure water voltage and 1 being the air. So none of these new values should appear outside of the range. For the fourth learning outcome, I then created a function to plot my live graph of the new normalized moisture values called prompt graph. And by assigning each to animated line here, we can update the values later down in the code so that the graph is constantly changing over time. The final learning outcome, when the button is pressed right here, the moisture sensor will begin to take readings of the moisture voltages in the soil. Then this will go back to the grow board and send the signal to MOSFET, depending on what reading it gets, if it's to send current from the battery to the pump or not. And then the pump will send water into the soil, and then this loop will continue if the soil dries up again or end if the button is pressed.